numerical problems on series and parallel circuits. So let us see the first numerical problem. In this numerical problem, we can see there are three resistors R1, R2 and R3. Resistance value of R1 is 10 ohms. Resistance value of R2 is 20 ohms. Resistance value of R3 is 30 ohms. Okay, so here these three resistors R1, R2, R3, they are connected in series, and these series connected resistors, across these series connected resistors, a voltage source of 60 volts is connected here. Okay, I'm not satisfied with this. Numerical problems on series and parallel circuits. So in this numerical problem, we have to find the voltage across the three resistances shown in the figure. So here we can see three resistors R1, R2 and R3. Resistance of R1 is 10 ohms. Resistance of R2 is 20 ohms. Resistance of R3 is 30 ohms. And these three resistors which are connected in series, they are connected across a voltage source. Okay, so these series connected resistors, they are across these three series connected resistors, a voltage source is connected. Voltage of this voltage source is 60 volts. Now we have resistances, we have voltage, and according to Ohm's law we know V is equal to I into R. So we don't have current, so we'll assume some current flowing in this circuit as I amperes of current. You can see an arrow mark, a loop, half loop has been drawn here. So I current flows through all these resistors, and we already know when elements are connected in series, the current flowing through all the elements will be same. So current through R1 is I, R2 is also I, and R3 is also I. Same current flows through all these three elements. And they have asked us to determine voltage across each resistor here. Okay, voltage across R1, voltage across R2 and voltage across R3. So first of all, let us determine I value, current in all these three elements. Now since these three are connected in series, if I want the total resistance of this circuit, then simply I have to add the resistance value. So the total resistance, that is the equivalent resistance or total resistance, Req is equal to R1 plus R2 plus R3. R1 plus R2 plus R3, 10 plus 20 plus 30. So if you add this, you will get 60 ohms. So total resistance in this circuit is 60 ohms. Now according to Ohm's law, I is equal to V by R. V by what is the total resistance, R1 plus R2 plus R3. Instead of writing R1 plus R2 plus R3, I can write R equivalent, total resistance, V by R equivalent. V is 60, R equivalent is 60, so 60 by 60 you will get 1 ampere. So the current in this circuit is 1 ampere. Now voltage across R1 resistor, VR1, is equal to the current I into R1 value. So this is the VR1 is the voltage drop across resistor R1. So the voltage drop across resistor R1 is VR1 equal to I into R1 So VR1 is equal to I into R1, where I is what? I is V by R1 plus R2 plus R3 into R1. So, or you can write V by R equivalent into R1. We have already calculated I value. 1 into R1 value we can write 1 into 10, you will get 10 volts. So you can directly substitute the I value here in this, but I have written all the formulas so that you can without calculating I value, directly you can solve and you can determine the voltage across resistance R1. So instead of writing all these equations, simply substitute I value 1, R value 10, 1 into 10 you will get 10 volts, or you can use these formulas and you can recalculate whatever you have done here. So it's wastage of time. Simply you can write I equal to 1 and R1 equal to 10 volts. R1 equal to 10 ohms, and 1 into 10 you will get 10 volts. So this is it. Now let us see the voltage across R2 resistor. Voltage across R2 resistor is I into R2. I is 1, R2 is 20. So 1 into 20 you should get 20 volts. So instead of directly writing 20 volts, so I have written I formula here again I have written I formula V by R equivalent into R2. So V by R equivalent 60 by 60 into 20, that you will get 20 volts. No need to do all this. You can simply, as you have already calculated I value, you write I value as 1 into R2 value as 20. 1 into 20 you will get 20 volts. Similarly, voltage across resistor R3, VR3 is equal to I into R3. I is 1, R3 is 30. So 1 into 30 you will get 30 volts. So I have written all the formulas here, but no need to write all the formulas again and again and to solve. So we have determined all the voltages across each and every resistor. Let us go to the next problem. In this next problem, we have to find the magnitudes of total current through R1, R2. Okay, if R1 is equal to 10 ohms, R2 equal to 20 ohms, and V equal to 50 volts. So here they have asked us to determine the total current. So I total. So IT. Here it is written IT, that is the total current. And they have asked us to determine the current through R1. Current through R1 is, let us assume I1, already it is given in the diagram itself, I1, and current through R2, so that is I2. So we have to determine IT, I1, I2, and the data that has been given to determine IT, I1, I2 is R1 value. R1 is 10 ohms, R2 is 20 ohms, V is 50 volts. Okay. So by looking at this diagram, what we can say that is that it is understood that this resistance R1 and R2 both are connected in parallel. So this I total current that is reaching this node will divide into I1 and I2. So IT is equal to I1 plus I2. Okay. So there is a rule which is known as current division rule. According to that rule, I will expand the screen. Okay, according to that rule, if I want to determine I1 current, according to current division rule, I1 current will be equal to total current IT into the I1 current is flowing in this resistance R1. So therefore, opposite resistance. What is the opposite resistance of R1? opposite resistance of R1 is R2. Okay, opposite resistance of R1 is R2. So I1 is equal to I total into R2 opposite resistance by self resistance. I1 is flowing in R1. So R1 is the self resistance, R2 is the opposite resistance, plus opposite resistance. Okay, if I want to determine I1, this is the formula. I1 equal to I total into opposite resistance. I1 is in R1. So for opposite resistance for R1 is R2. R2 divided by self resistance plus opposite resistance. So if I want to determine I2, formula is I2 is equal to I total into opposite resistance. I2 is flowing in R2 resistor. Okay, I2 current is flowing in R2 resistor. Therefore, opposite resistance of R2 is R1. So R1 divided by self resistance, that is R2, plus opposite resistance, that is R1. Okay, so this is the formula to determine I1 current, this is the formula to determine I2 current. This is known as, so these formulas are obtained from current division rule. Okay, these two formulas are obtained from current division rule. So according to current division rule, I1 is equal to the total current, okay, that is entering at this node, okay, that is dividing at this node actually, that is of course that is entering this node, okay, into opposite resistance. In order to determine I1, since I1 is the current flowing in R1, to R1 opposite resistance is R2. So opposite resistance by self resistance plus opposite resistance. Similarly, if I want to determine I2 current, that is equal to total current IT into opposite resistance. For R2, I2 current is flowing in R2. So opposite to R2 is R1. R1 divided by self resistance plus opposite resistance. Okay. Now, R1 and R2 are connected in parallel. So let us determine the R equivalent. So R equivalent is equal to what? R1 into R2 by R1 plus R2. So what is R1 value? 10 ohms. R2 value is 20 ohms. So 10 ohms, R1 10 into 20 by 10 plus 20. Solve it, you will get R equivalent. So R equivalent is what? Total resistance in the circuits. What is IT? Total current. This is IT. IT is the total current. What is total current? IT is equal to total voltage, that is supply voltage by total resistance. Okay, supply voltage by total resistance will give me the total current. So total current is equal to supply voltage. How much is the supply voltage? 50 volts. So 50 divided by total resistance, or how much did you get? 6.67. Okay, so you just divided 50 by 6.67, you will get 7.5 amperes. So I total, we have got I total. So we have I total, just now we have calculated, we have I total. We know R1, we know R2. So you can calculate I1 and I2. So according to current division rule, so our I1 is equal to, so there is a mistake here, this is R1. This is R1. Okay, so I1 current is equal to, I1 current of the given circuit is I1 equal to total current into I1 current is flowing in R1, therefore opposite resistance of R1 is R2, R2 by R1 plus R2. substitute I total, R2 value, R1, R2 values, simplify it, you will get 5 amperes. Okay. Similarly, I2 current is what? I total into here, okay, this is R1, okay, R1 divided by R1 plus R2. So, okay, you can write R2 plus R1 or R1 plus R2. You are simply adding those two values, so it doesn't matter. Actually, in the previous slide, I have told you that it should be R2 plus R1. It doesn't matter. You are simply adding those two values, so you can write R1 plus R2. So, you just substitute I total R1 in the numerator, R1 plus R2, just add it and simplify it, you will get 2.5 amperes. So what is the total current IT? IT is equal to I1 plus I2. So you just add it, you will get 7.5 amperes. So same current you have already got here, same current, isn't it? This is IT, this is IT, and this is also IT, same current you will get. Okay, so this is it. Now let us go to the next numerical problem. Here they have asked what is the equivalent resistance. Always remember, equivalent resistance means total resistance. Equivalent resistance means total resistance. They have asked us what is the equivalent resistance between the terminals A and B in the figure. Here there is terminal A, terminal B. So we have to determine the total resistance